Just like section 2, section 3 is going to continue to build on the principles in chapter 3, right? Nomenclature, you've got to know the alkenes first and then naming substituents. And in this video for section 3, we're going to learn how to name ethers, alcohols, and amines. And all of those rules you'll see just kind of continue to build on what we've already got, just with some different prefixes or suffixes. So let's look at each of them in turn, starting with ethers. If the slide wants to load, there we go. There are two types of ether that we need to pay attention to. Well, first, we need to know what an ether is, right? It's a compound with oxygen in the middle and two alkyl groups on each side. And whether or not those alkyl groups are the same will affect the type of name that we have. Because if it's a symmetrical ether, then the alkyl group is the same, which will play into our name. If it's an unsymmetrical or an asymmetrical ether, right, then the alkyl groups on each side are different, as we see here from R and R prime. When you see that R prime, it indicates a different alkyl group than just an unlabeled R. Okay, you could also get R double prime or R triple prime. We'll see those later on, just saying they're different. Okay? And I've told you in past videos that systematic names are the only thing that will be tested, which is true. Okay? But I will let you know that for ethers, at least, the common names are actually more common, right? They're more popularly used than are the systematic names, just in the case of ethers in most cases. Okay, so you probably want to get to know both of those. That would be good practice. But it's not hard to do the common name of an ether. Okay? You just list both of the alkyl substituents in alphabetical order and then say ether. Right? So if it's a symmetrical ether, like right here, right, an ethyl group on each side, it's diethyl ether or dimethyl ether. Okay, and this one's just, you see it as ethyl ether pretty frequently because it's been around forever. Right, it's an old school anesthetic. If they're different, then you just put them in alphabetical order, right? Ethyl methyl ether or sec-butyl isopropyl ether, remembering that here sec-butyl comes first because B in butyl comes before I. Okay? Cyclohexyl isopentyl ether. Not hard to do the common names. Right? So know both of those. The systematic name, okay, takes the whole alkyl group, including the oxygen. So that's called no longer an alkyl substituent, but an alkoxy substituent when it includes oxygen. And then we name it, oh, I'm sorry, I jumped ahead here, with the OXY ending. Okay? So whereas an alkyl substituent ends in YL, now they end in oxy. Okay, so here you see some examples: methoxy, ethoxy, isopropoxy. Okay? So then you just name it as a substituent. Okay? Everything else follows that name. So down over here, right, I look at this. What's my longest carbon chain that I can get? 1, 2, 3, 4, 5. So I'm going to name it as pentane. With this group, the ethoxy coming off of carbon 1, and a methyl group coming down here off of carbon 3. Right, numbering it from right to left to get the lowest possible number. Otherwise, it would be 3, 5. Yep. And you've got 3 others you can look at here for practice. You are required to know the systematic names of ethers. Okay, so common name, systematic name. I'd recommend you know both. What about alcohols? Okay. Now, whereas a ether gets named as a prefix, okay, alcohols get named using a suffix. Okay, we should know the classification of alcohols as well, okay? And it's just like what we saw with alkyl halides. An alcohol is defined as having an OH group attached to carbon, okay? And what type of carbon that is controls the classification of our alcohol. If that OH is attached to a primary carbon, it's called a primary alcohol. Same thing for secondary and tertiary. Same exact type of classification. We've just taken the hydrogen of an alkane and replaced it with OH. And again, we have common names and we have systematic names. The common name is just taking the alkyl group followed by saying alcohol. But we're not focused on that. We're focused on systematic names, which are more common. You've probably heard these already: methanol, ethanol, butanol. And here, you've heard me use this term before, right? OH is called a functional group. And it's called a functional group because it's the center of reactivity, right? It controls how that compound reacts more than anything else. The presence of OH is more significant than the length of the carbon chain, for example. Okay? So when we have these functional groups, we use suffixes to identify the presence of the functional group. Okay? That's what the second bullet point is saying here. Okay? And we do that with an alcohol by dropping the E from the alkane, the parent hydrocarbon, and replacing it with OL. Right? So the name of an alcohol will end in OL, just like alcohol itself ends in OL. Right? But we do have to have a number as well to indicate where the OH is. Now in methanol and ethanol, it doesn't matter because, right, there's only one carbon in methanol. In ethanol, right, I could think about it as carbon 1 and carbon 2, but I don't have to put a number there because if I just flip the molecule around, it's the same on 1 or 2. Always thinking about these things in 3D. But after we get larger than that, okay, then I do need a number to indicate where the OH is because 3-pentanol and 2-pentanol are different molecules, okay, as is 1-pentanol. So you have to track where the number is going as well, okay? And there's actually 2 ways that are accepted to do this in the IUPAC system. You can put the suffix, or sorry, the number all the way at the beginning, right, 3-pentanol, or you can put the number right before the suffix itself. Okay. And the bottom examples here, pentan 3-ol and 3-methylhexane 1-ol, those are actually the newest addition. They are IUPAC approved, but they just were never really widely adopted, right? Chemists were like, oh, we're too cool for this new naming system, right? So the ones on the top are what are still most commonly used, where the number precedes the name of the parent hydrocarbon, right? So we don't need a number for pentane itself, so the 3 corresponds to OL, right? Or you can put the number right before the suffix itself. It's whatever you prefer. Both are accepted in IUPAC. Okay? But let's see how that affects some of the previous rules, right? Because sometimes we've got some ambiguity. Keeping in mind, one of our earlier rules is that we needed the largest continuous chain that had the most substituents if we had a tie, okay? But now, if I have a functional group, which alcohol is considered a functional group, anything that controls the suffix, right? We need to identify the longest continuous carbon chain that contains the functional group itself, which is a key thing to have in your notes, which doesn't change anything for these first 2 examples, but look at this one over here on the right. The longest uninterrupted carbon chain is 1, 2, 3, 4, okay? But that doesn't contain the OH. So notice this is named as propanol because 1, 2, 3 is the longest carbon chain that I can get that has the OH on it. And when you're doing your numbering, you number in the direction that gives the functional group suffix the lowest possible number, right? So notice, right, the alcohol is getting the 1. The alcohol is getting the 1. Over here, it's getting a 2 because nothing's in the 1 position, right? The lowest possible number for the functional group itself. Got 2 others there to check for practice. And then what if I have something with 2 OHs? Okay, not a big deal. You called something dimethyl before if it had 2 methyl groups. Here, it's just called a diol. Okay? D-I-O-L, diol. 2 alcohols, and you just need the numbers to say where they are. Okay? Everything else is the same. And we'll look at diols later on in organic too. They're actually really important to serve as protecting groups. But right now, just know how do you name it? Diol. If there were 3 of them, triol. Okay? Not difficult. Just building on what we already have. Okay. If we run into a situation where we have a functional group and a substituent, right? So a functional group is the alcohol in this case. A substituent is like a methyl or an ethyl or a halogen or an ether. I already alluded to this previously. The functional group itself gets the lower number. So over here, right, it's 1 and 3. Who gets the 1? The alcohol, not the bromine. So over here, it's 2. This could be carbon 2 as well, right, if I numbered from left to right, but I want the alcohol to have the lower number. So make sure you understand all of those. Pause the video, check those for practice. Yep. And more practice here. I've already mentioned what we have on slide 63. Parent hydrocarbon is the longest chain that contains the functional group, has to have that. We've seen this slide before. Give the functional group the lower possible number. But if you get the same number for the functional group, right? Again, building on what we've already had before, then go in whatever direction is going to give your next substituent the lower number, lowest possible number combination overall. Okay, so looking at this one in the middle, for example, it doesn't matter at first if I go from left to right or right to left, because in both situations, my alcohol is in position 4. But I number from right to left so that this methyl group is on carbon 2 and doesn't end up being on carbon 6. If you have a cyclic compound, right, so this is cyclohexanol, for example, you don't actually have to use a number to indicate the position of the functional group in a ring, because it's always assigned the 1 position. Okay, which is why I just have to call this 3-methyl cyclohexanol. I know this is carbon 1, so I just need to go 2, 3 and call it 3-methyl. Right? Notice it's not 3-methyl 1-cyclohexanol or 3-methyl cyclohexane 1-all, okay, because we know this is carbon 1. If you have 2 functional groups on a ring, then you would need numbers. Okay. More examples here. If you've got multiple substituents, you list them in alphabetical order, which you already know. Okay. So that wraps up alcohols with slide 66 here. It's a nice little recipe, for lack of a better word, and that'll get you through this whole chapter with nomenclature. Okay? You go substituent, name of your parent hydrocarbon, and then your functional group suffix. In this case, it's OL for alcohols, and your substituents. So far, we've seen alkyl substituents, halo substituents, right, from group 17, and we've also seen ethers can be named as substituents. Just remember to add numbers where necessary and put them in alphabetical order, and you're in business. So we finished section 3 here with amines. Okay. First, looking at the classification of amines and then their nomenclature. And notice that the classification of amines is different from alcohols and alkyl halides. Okay, so I'd put a star for that in your notes as well. The classification of amines depends on how many alkyl groups are bonded to the nitrogen itself. If it has 1 alkyl group, it's called a primary amine. 2 alkyl groups, a secondary amine. 3 alkyl groups is called a tertiary amine. Okay, so that depends how many groups are bonded to nitrogen, not the type of carbons the nitrogen is bonded to, just the sum, which is different from alcohols and alkyl halides. Okay. And that's summarized on this slide. Okay. You're only looking at the nitrogen when you're classifying an amine. Okay. Common names of amines. Put all your substituents in alphabetical order. Say amine. Okay? And the only difference from those other common names is there's no space for amines. Right? I don't know why I didn't make up the rules. Silly. But those kind of have mixed usage. Right? You've heard maybe methylamine before, the reagent. They talk about it in Breaking Bad. Right? But again, we're concerned with systematic names of amines. Okay? And amines, just like alcohols, control the suffix of the molecule. Okay? We dropped the E from alkane. We replaced it with OL for an alcohol. Here we replace it with the whole word amine. Okay? But I do have to have a number to say where the amine is attached. Right? So here, 4 carbons, that's butane. I drop the E off butane, replace it with amine, it becomes butanamine. But I have to say, right, is it 1 butanamine or 2 butanamine? Because I could have had the amine coming off here as well. And just like before, you can also put the number just before the suffix itself. What is new on this slide, right, is that any alkyl group that's attached to nitrogen, different from the parent hydrocarbon, right, because parent hydrocarbon is included in the main name, but if you have other alkyl groups that are branching off of the nitrogen itself, we precede it not with a number, but with N. So if we look at this middle molecule, right, what's my parent hydrocarbon? 6 carbons, so it's hexane, becomes hexanamine. Okay, 3-hexanamine tells me that the nitrogen's coming off of the 3 position. And N-ethyl indicates that there's also an ethyl group coming off of that nitrogen as well. Over here, N-ethyl, N-methyl, propane, 1-amine, right? Coming off of carbon 1, or 1-propanamine. And here you've got some more to look at for practice, okay? I recommend, oh, these are actually the same ones. It's just different text. Here we've got some other ones for practice. Okay. Always listing the substituents in alphabetical order. Okay. In this situation, even if they're attached to the amine, you know, preceded by N, they're still going in alphabetical order overall. Right? So notice, like right here, for example, N-ethyl means the ethyl's off of the nitrogen. 5-methyl means I've got a methyl group off of the parent hydrocarbon. Okay. But they're all coming in front. They're all alphabetical. And that N, of course, does not affect how they're alphabetized, just like the numbers don't. Okay. Lastly, if I have a quaternary ammonium salt, okay, that means I have 4 groups bonded to nitrogen, so I have a +1 formal charge. Okay. I name the groups in alphabetical order, however many there are, right, if they're different, and then you follow it by ammonium and the counter ion. You always have to have a counter ion because nitrogen is positively charged, so I followed by something with a negative charge, right? Chloride here, hydroxide there. 4 methyl groups, tetramethyl ammonium hydroxide. Over here, ethyl, dimethyl, propyl, ammonium chloride. And I don't have to include the N's in this situation where it's a quaternary salt because I'm listing them all going around the nitrogen by default. Okay. All summarized here on slide 74. And I would review this table and make sure you know what it's all about. We've got lots of rules, right? Alkanes and alkyl groups come first, then alkyl halides, ethers, alcohols, amines. It's a lot, right? Practice makes perfect, but make sure you practice these things, get it on your sapling, right? Go through everything in the slide, make sure you understand how to name it. Test yourself because these will definitely be on the exam. Okay? We're going to take a break from nomenclature moving forward and start talking about their structures and physical properties in the next video.